Assalamu alaikum warahmatullahi wabarakatuh. Now in chapter 2, engineering design, we will study about design goals and specifications. Okay, for 1 minute, we will recall our chapter 1. We studied in chapter 1 about the definition of an engineering, definition of engineer, and qualities or attributes of an engineer. We studied about the design engineering process, step by steps, in steps and in flowchart. Now, in that steps and flowchart, the first point was how to define a problem. We studied in chapter 1. And in defining a problem, we studied what is the problem statement, and we studied design notebook and mind map and concept generation. These all we studied under the defining a problem. Now, coming to the chapter 2, design goals and specifications. Okay, so before generating before we will get a final solution, we must have some goals or objectives, we can say, and it must have some specifications which has to be followed, which has to be designed. So these we'll study in this chapter 2. Okay, coming to the next topic, that is how to set the goals or specifications. Now, before going to that, first we have to understand the strategy. Design search strategy means how to put a step-by-step method or path to create that solution. In order to structure the path to be followed to a final design solution, we need to consider and compare aspects of the problem and solution state. So, to get a final design solution from the problem which we already defined, we must follow some path to get that final solution. Okay, design our tasks so that they are most fruitful. So the designing should not be such that it will give huge loss, time waste. It's not like that. It should give very fruitful results. That is so that they will provide the most information or guidance in our problem solving effort. So the path which we are following must give a proper information, proper guidance, so that anyone can understand and they can follow. We begin with the need to eliminate impossible or unpromising paths between the problem state and the solution state. Means once we set this path, the steps which has to be followed to get the solution state, some steps can be eliminated which are not able to be covered or which are not able to be followed. You have to remove that one, which are unpromising and impossible, like that. We'll study in deep in the future how to eliminate and what are those unpromising paths. Okay, these are the items in search strategy. Let's have an example. One example is 12 coin and scale method. What we are doing, among the 12 coins we have, let's take 12 coins, 11 are normal in that and one is heavier in weight, the wazn. Determine which coin is heavy and by using a balance scale no more than 3 times. So we have given a balance scale. We have to use only 3 times that scale to get the heavy coin out of 12 coins. Here, if non-engineering person, he will use the scale for 12 times. More in worst case, in 12 times, he will get the result which is heavier. But this is not the optimal solution. The engineers must use some constraints and use some time limits and economic factors he will consider. Then only he will get a solution. So then this is called good engineering. So here also the constraint is 3 times only we have to use the balance scale. Let's take this problem is similar to one in engineering design since we must work within real constraint. We can use balance scale only thrice and we must find the true solution to the problem. Next, what is the possible path or strategy that guaranteed success? So in these three weighing of the scale, what is the guarantee of the success? We'll see. Okay, one possibility is the sequence of weighing, which will show in the figure in a later case. We first place 6 coins on each side of the balance. We'll place the 6 coins on each side of the balance so that it will give some result, which wherever the heavy coin is there, that will tilt down. See here. The scale must be then tipped downward in one direction or other, since the heavy coin must be among 12 coins on the scale. So 6 coins left, 6 coins right, the heavy coin will be either side. So it will tip downwards, which where the heavy coin is available. Assuming that it tips downwards to the right, we know that the heavy coin is among the 6 on the right side of the scale. The number of coins has been reduced from the 12 to 6 by first weighing. This, just see here. So we have 6 coins left side and 6 coins on the right side. Then it can result by tipping down to the left side or tipping down on the right side. Now if it is tipping down on the right side, then the coin is in the right side 6 coins from 7 to 12. If it is tipping down on the left side, the coin is among the coins 1 to 6 on the left side, right? So we can eliminate the other part, other 6 coins, we can remove it, and we can consider only the tipping towards coin side. Okay, next, what the next weighing. Now in the next weighing, second weighing, we have only 3 weighing. So first weighing finished. Now second weighing, we then weigh these remaining 6 coins by placing 3 of them on each side of the scale. Once again, the scale must tip downwards, indicating which set of 3 coins must include the heavy one. Only 3 candidate coins now remain to be evaluated. So same like with the previous one, here also we divided into 3 coins and we put on the weighing scale left side and right side. Then which is the heavy one, that will tip downwards, and that 3 coins only will consider, remaining 3 we will throw it, means we will not consider. See here, same like previous one. Now we have only 3 coins here. Now which side it is tipping downwards, like this, 2 results, one result will take, and that in that result the tipping downwards coins will consider, other coins will remove it. Now the last weighing one, third time we are using the scale now. Finally, on the final weighing, we place 2 of the remaining 3 candidates on the scale. If it remains balanced, the third candidate of the scale is oddball. Otherwise, the heavy coin is the one indicated by the imbalance of the scale. So what it means here, now we have 3 coins, only one time we can use, last time we can use the weighing scale. So 3 coins, how can we put on this one? Because if we put 2 coins one side and one coin on side, surely it will weigh on the right side, but result will not come. So what we are doing, we are putting out of 3, 2 coins we will put on the weighing scale. One we are not keeping on the weighing scale, we are keeping aside. So when it tipping down on the right side, then the heavy coin is on the right. When it is tipping down on the left side, then the heavy coin is on the left side. If the scale is balanced one, then what happens? The remaining coin which is not on the scale, that is the heavy coin. So like this, in these 3 uh, cases, we will find the solution. This is the one. When one is kept outside the weighing scale, 2 coins are kept on the weighing scale. If it is balanced, then coin number 3 is the heavy one. If it is tipped left side, the coin number 1 is the heavy one. If it is tipped right side, then the coin number 2 is the heavy one. So what will get the result? No matter what happens during each of the 3 weighings, the above strategy guarantees that we will identify the odd coin, means heavy coins. So we eliminated impossible solution coins that could not be a heavy one, with each weighing until only one possibility remained. So like this, the strategy or path should be followed to get a better solution. Now we'll go to the design solutions. We'll study one by one. What are the design goals? Sorry, design goals we'll study. We have I think 10 design goals are there. As per my knowledge, one by one we'll study. First, I will mention the names of the design goals or objectives also we can call. The page number is mentioned 123. Safety, environmental protection, public acceptance, reliability, performance, ease of operation or operating conditions, durability, use of standard parts, minimum cost, minimum maintenance, and ease of maintenance. So 1, 2, 3, 4, 5, 6, 7, yeah, 10 design goals or objectives we have. So we have to study one by one what are these design goals. First one, safety. A paramount goal of engineering is to produce truly safe products, systems, and process. A design solution should not threaten the safety of those who will produce, distribute, or operate it. Design engineers should always consider safety of the users. So here, the safety of the user should be considered, uh, that the product should be safe or not. For example, let us take, we have car windshield. In previous years, when the car was manufactured, we used to have a windshield with a glass. Now also it is a glass, but I will tell what is the different process in it. When normal glass was placed on the windshield, so while driving, or due to the vibrations, due to the accidents, the glass used to broke, and it will harm the driver or the passengers inside the car. So that's becoming very, very, very dangerous as per the safety concerned. It will cut the arms or parts of body of the uh, passengers and the driver. So this is not good. So that's why the engineers, what they thought, we have to improve the safety of the car. Then only we can sell the car in the market easily. So they, what they did, they put some glues, some glue, pasted some glue on the glass, transparent glue, and they put, so that when it is broken, it will be attached to that glue, because glue cannot be like a plastic. You can say glue, it will work like a plastic. On the plastic, the glass will be there. So when it is broken, the glass will be outside, not inside the car. Inside the car, it is safe. But it is safely, but the problem came for the long run. When we are using the car for long run, maybe for 6 months, 1 year, like that, then due to the sun intensity, or due to the light, the glue becoming yellowish. The glue was previously transparent. No, no problem. Safety was good, looking good, transparent. It was there. We can see the road. No problem. But now, on the long run, the glue becoming yellowish nature due to its chemical reaction, due to the sunlight. Then we cannot see the outside roads. So this is becoming problem for the quality of the car. Then the engineers thought, okay, this is not the good one. We can have final solution like two glasses. We can use it in between, some gap or some resin material will be there, so that when it is broken, it should be broken in a crystal manner, not in a exactly the glass manner. Small parts of the glasses will be like a crystal, like a cubical glasses form shapes it will take. They added some what we call material while manufacturing the glass, so that when it is broken, it will get small pieces, small cubical pieces, which will not much harm the, say, the people inside the car. Okay, so like that, we have to consider the safety day by day. We have to improve the safety of the product. So previously we don't have any what we called airbags in the car. Now we have airbags. Whenever we are hitting, the airbags will open. So like that. So we have to consider the safety of the product towards users. Environmental protection. Design solutions to technical problems should never harm our environment. From their protection through their operating lives to their final disposal, engineers must strive to anticipate by and eliminate any hazards to environment and their designs. Here, environmental protections, for example, let us take, you are using car lead acid battery. Previously, we used to have a lead acid battery where the chemical is H2SO4, sulfuric acid, HCl, or different acid used to have. But while you are using the lead acid battery for in running conditions, the acid used to be leak, and the fumes used to come out due to heat while it is operating, which is affecting the environment. And final disposal. Now when you are disposing the battery, that also a problem for the environment. How many batteries will dispose every year for each car? So the environmental protection should be considered in this. Nowadays we have better batteries like lithium ion, lithium polymer batteries, which doesn't have any liquid chemical inside. Only it has the hard chemical, which is not in the liquid form. The, we can say, solid form we can have. So which are lightweight and which doesn't give fumes or hazardous fumes, or which can leak, which can not leak. So like this we are improving our technology so that environmental effects will be less. Next, public acceptance. In order to ascertain if any expectations exist about a product, potential customers should be identified as precisely as possible in terms of such factors as their mental and physical abilities, economic means, and most importantly, specific needs that are be satisfied by design solutions. Means product should be designed based upon the physical abilities of the public, mental abilities, and economic means. Also means you have to identify group of people to which that product is useful, like mobile phone, with all features of mobile phone is used by the different people. Some people use like a camera. They Some people only like camera, photographic people. They will go and you take the photographs. They are only concerned about the photography. So based upon that, we have to design one model. Some people needs multitasking, so that the RAM of the phone should be high. So like that, one model should be designed like that. Some people only want calling. Then the fastness of the mobile should be good. So we have to you design such a mobile. So one example it is I'm telling. So like this, public acceptance should be there, and we can have feedbacks from the public how they require that product. Then we can design as per that. Now, so this is your public acceptance. Another one, reliability. The design solution should perform each and every time it is used. At least this is ideal level of reliability sought by engineer. For example, a reliable camera is one that operates every time it is used. So a camera, when you are using, every time when you are using, it should operate same like a first time, or it should operate in in good results. It can operate, it can give good results. First for 6 months it is operating good, in second 6 months it's giving blur images and it's not giving proper results, then the reliability is less. So reliability is for any time the result should be same, that is called reliable. Performance. An engineering design should perform well in the given environmental and operating conditions. So the design should work in all the environmental and operating condition, temperatures or power. In all conditions we have to it has to work same. A camera can be reliable but nevertheless perform poorly. Okay, so camera is reliable, but based upon the temperature and operating conditions, let us take it is not operating properly. Then it is best. It should be reliable and performance should be good. In order to enhance performance, to get the performance, engineering team should anticipate. You should think about the reaction of the design to its environment, like temperature, humidity, intensity of loads, or applied forces, or so forth. So that your design should work in all these conditions, different temperature conditions, different humid conditions, intensity of loads, how much load it can take, and applied forces from the outside. And another thing, he can identify its ability to operate according to specifications. Example, duration of operation, power requirements. So these are the items which has to be considered while checking the performance of the device. Ease of operation, operating conditions, also known as ease of operation. How to use that one very easily, we can operate that one. Ease of operation. In the design should be easy to understand and easy to operate. The design should be easy to understand and easy to operate. It is imperative that the user be identified. User populations with different abilities and needs will be required different levels of ease. So the operation should be very easy to understand and easy to use it. So that's he's telling. Otherwise, no use. So and based upon the users who can use this one, elderly people or child, so you have to separate the design. Durability. Any product must be designed to resist wear and operate properly for a specified amount of time. The durability of the system components may vary. but the design should include provisions for minimizing wear of certain key components, such as provisions for lubricating moving parts or use of specific wear resistance materials. Durability means how much your design is performing well, strong, it is strong enough or not. Any product must design resist wear and operate properly for specified amount of time. Means for long run it should be same quality, it should be given. Means for small maintenance it should give the good outputs. Next, use of standard parts. Many standard or off the shelf parts are available in the marketplace from manufacturers. These should be incorporated into a design whenever possible, since it is usually less costly in terms of money, effort, and time to purchase these ready made components than to fabricate them from raw materials. Fabrication repair expenses may result in the design being rejected as infeasible. Catalogs and handbooks should be provided for the guidelines of on the use of such components. What do you mean this here? Use of standard parts means once you manufacture something, the parts for its running operation or for in future use, it should be available in the market easily. And how to use that parts, the catalogs and handbook should be provided. It means once you have purchased a car, let us take, then the parts should be available in the market, so that in future you want to replace or exchange the parts, it is easy to you to purchase from the market and to replace it. And you, it should not be such part, should not be such like that it is available but I cannot replace it because I don't know how to replace that one, what is the procedure for it. So the procedures and the specifications should be mentioned in the catalogs and handbooks for such parts. That's its selling. And for example, standard values for such components, characteristics as size, electrical resistance, and viscosity often can be found in handbooks. So the handbook should contain all these items, characteristics like electrical resistance, size, and viscosity, like that, and so that the user can understand which part is suitable for which device. So these recommended values help us to select components that will perform properly under a given set of operating conditions. Okay, so this is the use of standard parts. I think last two or three are there. Yeah. Cost includes Costs include those for design and development of the solution. What is the minimum cost? We have to maintain the minimize the cost of the production, which includes the production, distribution, advertising, and promotions, and so far. So you have to consider all the cost, and these costs should be minimized so that your item cost will be less when it is going to be sell in the market. The challenge in reducing the cost is to do so while simultaneously maintaining or increasing the quality of design. You should not be such that you are decreasing the cost, but your quality of the item is also decreasing. It's not acceptable, because in the competitive world, the same specification products are many are there. So in that, they will compare the quality based upon the cost also. Like mobile, we have same specifications mobile, China mobile also we have. Let us take, we have Apple mobile, same specifications available. Then based upon the quality, they will not purchase the China mobile, they will purchase only Apple. Maybe the costly, but the quality is very good. So you should not reduce cost such so much that the quality is degraded or quality is decreased. So be careful about that. Our list of general engineering design goals also includes the need to minimize cost whenever possible. We have to minimize the cost whenever it is possible. Otherwise, a proposed design may be deemed economically infeasible and never produced. So, if it is more costly items you are putting, production cost is high, distribution cost is high, everything is you are putting very high, then it is not economical and the product will not sell, because you have to put the high prices on that. Otherwise, another problem, unexpected cost may cause a design to become economically infeasible after production has begun. Okay, unexpected costs. We don't know. Sometimes we have to add something to your design, as some engineering problems are coming. So we have to include that cost. Then what happens? The production already began, but the many costs we are adding in that. Then it will lead to its commercial failure, but it will not give a good results. Okay, another one, cost may be reduced in an arbitrary fashion, leading to design or manufacturing flaws. So sometimes what happens, your product is ready, you are selling, but due to some problems, flaws in it, some uh, loopholes in it, we have to reduce the cost day by day. Then what happens, you will be in the loss. So this also uh, minimizing the cost problems. Okay, so be careful for that. Okay, minimum last one, minimum maintenance and ease of maintenance. Two other general engineering goals related to durability are to minimize any necessary maintenance work and to ensure that such work is as easy to perform as possible. To get the reliability to the durability and to get the good engineering goals, we have to minimize the maintenance work, and the maintenance work should be easy. It is important. Otherwise, the user will be angry, and they will be saying that, oh, it is not useful for me. It is getting more maintenance cost, and it's not easy to maintain also. Maintenance often includes the regular inspection and replacement of parts, reminding us that systems should be designed to allow for proper and easy inspection. So the design should be such that we can easily inspect, and it can be replace the parts very easily. A handy replacement, we can say. For successful, competitive, and safe product, maintenance should be minimized and, if possible, eliminated. Made easy. Like batteries, we used to have car batteries, lead acid batteries. We has to maintain in previous case. We have to put some heavy water in that to run properly for every few weeks or every month, like that. Nowadays, maintenance free batteries we are getting. Once you install it, to its lifetime, means its operating span of its life, no need for any maintenance. It is have some years span of years of life, maybe 3 years, 4 years, or 5 years. After that, you have to throw it. In between, no need any maintenance. Just use and throw it, like that. So you have to minimize the maintenance, and maintenance should be easy. So these are the design goals or objectives which has to be considered in the designing. Okay, now we'll go for the design specifications, chapter 2, last topic. In these specifications, you know the specification, what it means. Physical specifications will come, functional or operational specifications will come, environmental specifications will come, economic specifications, and legal and human factors. These are specifications we have to be considered. For all products, no need to consider all specifications. Some products only needs physical and legal. Some products may need environmental and human factors. Based upon these are the major specifications factors should be considered in the designing. One by one we'll study. The next one is physical. What is physical specification? Space allocation or dimensional requirements comes under physical allocation. Means how much space should allocate it, or how much space it should specify for the product. It means weighing weight limits requirements, like your mobile phone should not be heavy, and it should not be very light. So it's called weight limit requirements. Material characteristic requirements means the material what you are using for your product, it should be so strong, rugged, so that it will not damage easily. So material characteristic requirement should be considered. Energy or power requirements, so like your refrigerator or AC, it is using more power, your electricity bill is very high, then it is not feasible, it is not considered in the market. So energy and power requirement should be considered. So the next one, functional or operational. In this functional operational, acceptable vibrational ranges, like you are driving a car. When you are driving a car, the vibration should be very less. Okay, And if it is vibrating more, your health problem will come, or you will get angry on it. Acceptable vibration ranges while operation. Operating times means like battery, which is mentioned. The battery can be recharged for 100 times or 150 times, 200 times, not more than that. So if it is more operating times is specified, then it will be good for the product uh, to be sold fast. Now coming to the environmental. Coming to the environmental, we have moisture limits. So your product should not produce or should accept the moistures in the nature. And dust levels, you should not absorb the dust proof, like mobiles you are getting moisture free, dust proof, scratch resistant, like that. So environmental this intensity of light means the light produced by your product should not harm the other people in the environment. So this intensity of light. Temperature ranges, the operating temperatures of your product should not affect the environment. Very huge heating effect is getting affected by nearby plants or other users in the environment. So temperature ranges. Noise limits, you should not produce your item product should not produce limits so that it will affect the environment, like other birds, other human being. Noise limit should be considered. Potential effects upon people or other systems that share the same environment. If you are say we are sharing the same environment, means in one colony or one area, your top industry is there and residential area also is there. You are sharing the same environment there, but the industry which you are producing some products, or which are producing some electricity or something, should not affect the environment by which the nearby residential area should be affected, or nearby trees are affected. So this is called, you should not be sharing the same environment. So this is about the environment. Last three, economic. In the economic limits should be kept, keep on economic limits should be keep on production cost. We have to keep on the economic limits. Depreciation cost. Depreciation means when you purchase something after so many years, when you are selling it, what are the amount you are getting? The differentiation is nothing but the depreciation. Its cost should be difference should be low. Means when you are purchasing it, when you are selling, the selling price should be near to the purchasing only. The reason depreciation is low, then the product is very good. It should be limits. Operating cost. The operating cost, when you are operating, how much cost you are spending, like electricity bills or any other things. So operating cost should comes under economic conditions. Service or maintenance requirements. So for maintaining your product is always how often you service it, how often you change the products, change the parts in it. So it's a maintenance. Service and maintenance requirements comes under economic also. You should not pay more for that. Last one, existence of any competitive solution in the marketplace. Your product should be such that there should be a easy solution to get rid of it. I means there will be easy solution, easy part should be available in the market. Otherwise, we will go for the other type of results, other type of devices. Legal aspects, governmental safety requirements. Government must impose some safety requirements on your product, so you have to follow that one. Legal aspects. Next, environmental control codes means this much temperature it has to be maintained, and this much operating conditions it has to maintain. So some environmental control codes will be there. You have to follow that in the legal aspects. Pollution control, like if you have factory or if you have a car, the fumes coming out from the car, the pollution coming out from the car, we have to follow some codes. Means if it is more coming out, it will be legally penalized. So you have to follow that one. Production standards, we have to follow some production standards set by the government or set by the policies. So these are the legal aspects. The last one, human factors. Strength of the user. Means based upon the strength of the user, we have to design a product. You cannot design same product for all the categories of the users, like childs, teenagers, or the elderly people. As per the strength of the users, you have to design the product. Intelligence of the users, same thing. As per the intelligence of the users, child, teenagers are the this one. You have elderly people. The part should be designed. Anatomical dimensions of the user based upon the height, based upon the size and weight also, which can be described the design, because some countries high, very high people will be there, very height people will be there. Some countries very light, less what you call height people will be there. So based upon that we have to design. So this is about the all six specifications we have to follow. Okay, I hope you understand. If anything is there, you can reply me on the WhatsApp or reply me on the Blackboard. Any doubts, I will clear it, inshallah. Thanks for attending.